Hello friends, I welcome you all to this session on graph theory. So today what I'll be doing is I'll be introducing you with the theorems. So before I introduce you with any of the theorem, you should be understood about or you should be clear about two things. The first thing is what is basically a conjecture, and the second important thing is that what is a theorem. So there are so many observations which we can make about any particular thing. So those observations are what we called as conjectures. So unproven statements are basically the conjectures. Whereas the theorem is the one that has a proof, or the conjecture once proved becomes a theorem. So let us start about the theorems of graph theory. So we will be discussing about some in this lecture and some in others. So consider three graphs. So they are the graphs, and the terminology will be like this, that the number of vertices in any graph I will be calling it as n, whereas the number of edges will be called as m. So n is nothing but the order of the graph and m is the size of that graph. So if I write one by one the order, size and the degree of vertices in every graph, and also sum of the degrees, that is total degree for that particular graph, then for the first one I'll be getting two vertices, size is 1, degree of a and b both is 1 1, and if we sum up the degree of vertices I'm getting 2. The same thing I will be doing for the second graph. So the order is 3, size is 5, degree of A, B and C are 3, 4 and 5, 3, 4 and 3 respectively. Whereas the total degree of this graph is 10. And for the last graph, the order is 5, the size is 9, the degrees of A, B, C, D and E are 5, 4, 4, 3, 2. And when you sum these up, you will be getting the total degree as 18. Now, what can you observe? The first thing which you can observe is that here, here and here, that whatsoever the graph it may be, the total degree is coming out as even. So this is one observation, that the total degree of any graph will always be even. The second thing is, if you observe the total degree in any graph and the size of that graph, that is this one. Now in this case, if you multiply the size by 2, that is m by 2, so that will become 1 times 2, that is 2, and that is coming out to be equal as the total degree of that graph. The same thing you can observe here as well, that the total degree of this graph is also equal to twice the number of edges in that graph. And here also, the total degree is twice the number of edges, that is 18 is 2 times 9. So two observations which we have made from this particular slide is, the first one is that if I am having a graph, then the total degree of that graph will come out to be even. And the second one is that the total degree will be equal to twice the number of edges in that graph, or twice the size of that graph. So the first theorem says that the sum of degree of the vertices in a graph will always be equal to the twice the number of edges. That is what we have observed. Now again we have to look these. Now if you watch the degrees closely, that in each graph you will be observing that for the first graph how many vertices are there, 2, and both are having what, 1 1 as the degree, that is odd number. Whereas in the second graph the same thing you can observe, that A and C vertices are having odd degree, that is 3 and 3. And likewise in the third graph, the vertex A and the vertex D are having odd degrees. So if we count the number of vertices having odd degrees in all the three graphs which I have shown, then you will be getting 2. And what is this number? This is an even number. So if I am having a graph, then the number of vertices having odd degree will always come out to be even. That is, it can come as 2, it can come as 4, 6, 6 means the numbers. So 2 vertices can have odd degree, 4 vertices can have odd degree, 6 vertices can have odd degree, but you will never ever see a graph in which there is there is odd number of vertices having odd degrees. That means you will never find a graph in which one vertex is having odd degree, or 3 vertex they are having odd degrees. So this will never ever happen. So this becomes our third observation, that the number of vertices having odd degree in any graph, that number should always come out to be even. So therefore, in a graph, the number of vertices of odd degree is even. So this is our corollary for theorem 1. Likewise, the total degree of a graph is even. Okay. Now, we can verify the thing which we have learned so far for this particular graph. Now, if you note down the number of vertices, edges, degrees of each vertex as well as the total degree, so this is what you will be getting: 5 vertices, 8 edges, and the total degree of this graph is coming out to be 16. Now, here also, if you multiply the number of edges by 2, that is 8 times 2, it becomes 16. So what you have proved? You have proved that the total degree in any graph is equal to twice the number of edges, or you have seen basically. Similarly, as 16 is even number, so the total degree will always be even. And how many vertices are there in this graph having odd degrees? So they are 2, that is vertex C and vertex E, and this 2 is even. So therefore, the number of vertices having odd degree will always be even. So this shows or demonstrate that this is also present in this particular graph. So in all the graphs, you will always find these three things. First, the total degree will always be even. Second, the number of vertices having odd degree will be even. Third, the sum of degree will always be equal to twice the number of edges. And if anyone violates, then that particular graph is not a valid graph. So now you know three things, and then with the help of these three things, you can do many problems or tasks. So in this lecture, till this point only, in the next lecture, what we'll be doing is we will be learning about the proofs of these theorems. So thank you very much for watching it.